evaluating the severity and extent of wildfire damage. Wildfires can cause widespread destruction, leaving a trail of devastation in their wake. Assessing the severity and extent of wildfire damage is crucial for understanding the impact on ecosystems, infrastructure, and communities. In this tutorial, we will explore key methods and techniques used to evaluate post-wildfire damage. Remote sensing is a powerful tool for assessing wildfire damage on a large scale. It involves gathering information about an object or phenomenon from a distance, typically using satellite imagery or aerial photography. Remote sensing is divided to satellite imagery and aerial photography. Satellites equipped with high-resolution sensors capture images of burned areas, which can be analyzed to determine the severity and extent of the damage. Various indices, such as the Normalized Difference Vegetation Index, NDVI, can be derived from satellite imagery to assess vegetation health and recovery patterns. Similarly, aerial photography provides detailed images of the burned landscape. These photographs can be used to identify visible changes in vegetation, soil erosion, and damage to infrastructure. Field surveys are essential for obtaining ground truth data and verifying the findings from remote sensing analysis. These surveys involve physical observation and documentation of wildfire impacts within the affected area through walkthrough surveys, transect sampling, and soil sampling. More specifically, walkthrough surveys involve systematically exploring the burned area on foot. By noting the severity of fire damage to vegetation, structures, utilities, and soil, a comprehensive understanding can be gained. Transect sampling involves establishing sample lines or linear paths within the burned area and collecting data along those lines. This method allows for systematic data collection and the calculation of damage metrics such as percent burn severity. Lastly, analyzing soil properties is crucial for understanding post-wildfire impacts. Soil samples can be collected at different depths to assess burn severity and analyze changes in nutrient content, organic matter, and soil compaction. Computer models are valuable tools for simulating and predicting post-wildfire damage. These models use variables such as weather conditions, vegetation type, and terrain to forecast the severity and extent of fire impacts in an area. Computer modeling can be categorized in fire behavior model and water erosion models. Fire behavior models utilize data on fuel type, weather, and topography to simulate the spread and intensity of wildfires. These models help in understanding the factors that contributed to the extent of the fire and its effects on the landscape. As far as water erosion models are concerned, post-wildfire erosion can greatly impact soil stability and water quality. Water erosion models estimate erosion rates and predict sediment yield using inputs such as burn severity, precipitation, and soil properties. This information is critical for land management and mitigating erosion. Several specialized tools and techniques are specifically designed to evaluate wildfire damage and aid in assessing the severity and extent of the impact. Damage assessment tools include damage assessment guides and unmanned aerial vehicles, WAVs. Damage assessment guides are developed to provide standardized procedures for assessing different aspects of fire damage, such as vegetation, infrastructure, and cultural resources. They serve as a reference and aid in data collection during field surveys. UAVs, or drones equipped with high-resolution cameras and sensors, have become increasingly popular for assessing wildfire damage. They can capture detailed imagery and provide an efficient means to survey large areas. In conclusion, evaluating the severity and extent of wildfire damage requires a combination of remote sensing, field surveys, computer modeling, and specialized assessment tools. By employing these methods and techniques, a comprehensive understanding of the impact of wildfires on ecosystems, infrastructure, and communities can be gained, helping in post-wildfire recovery and management efforts.